Hello, everyone. Good evening. So here we shall solve the question number 17 and 18, exercise 2 in the chapter Trigonometric Identities. The question number 17, exercise 2, has been told that if sec theta plus tan theta, that is equal to b, then we have to prove that sin theta, that is equal to b square minus 1 by b square plus 1. So as we know that secant square theta minus tan square theta, that is equal to 1. So now as you know, a square minus b square is a plus b into a minus b. So therefore the secant square theta minus tan square theta can be written as sec theta plus tan theta into sec theta minus tan theta. That is equal to 1. Therefore this is equal to p into sec theta minus tan theta. That is equal to 1. Therefore sec theta minus tan theta, that would be equal to 1 by p. Now if we add these two, equations, then we will get the value of sec theta. Therefore, if you add these two equations 1 and 2, then we will get 2 sec theta and tan theta will get cancelled. That is equal to p plus 1 by p. So therefore, I can say 2 sec theta, that is equal to p square plus 1 by p. Since if we take the LCM of the derivators, then we have LCM is p, and the numerator will give p square plus 1. So therefore, sec theta will be equal to p square plus 1 by 2p. So therefore, sec theta is the reciprocal of cos theta. So this cos theta will be equal to 2p by p square plus 1. So now, therefore, sin theta as we know, that is equal to square root of 1 minus cos square theta. So this, or you can do it like this also. We can find out tan theta from here. If we subtract the equations 1 and 2, then we will get 2 tan theta and sec theta will get cancelled. Then we will get 2 tan theta, that is equal to p minus 1 by p. So therefore 2 tan theta, that is equal to p square minus 1 by p. So tan theta will be equal to p square minus 1 by 2p. As we know, tan theta is sin theta y cos theta. So sin theta y cos theta is p square minus 1 by 2p. And so therefore I can say, therefore sin theta will be equal to p square minus 1 by 2p into cos theta. And cos theta is, we have found it as 2p by p square plus 1. So this will be equal to p square minus 1 by 2p into 2p by p square plus 1. So 2p and 2p will get cancelled. So that if we get it as p square minus 1 by p square plus 1. So we have proved that sin theta is p square minus 1 by p square plus 1. So hence proved. Then in the question number 18, has been told that sec theta plus tan theta, that is equal to p. Then obtain the values of sec theta, tan theta, and sin theta in terms of p. In terms of p, we have to find out. So as we know, sec theta plus tan theta is p, then as we know, sec square theta minus tan square theta is equal to 1. So if we factorize it, then we have a square minus b square is plus b into a minus b. So sec theta plus tan theta into sec theta minus tan theta, that is equal to 1. So therefore sec theta minus tan theta, that will be equal to 1 by 3. So therefore if you add these two equations 1 and 2, Then we will get sec theta, since tan theta will get cancelled. So 2 sec theta, that will be equal to p plus 1 by p. So therefore 2 sec theta, that is equal to, if you take the LCM will be p, and in the numerator we will have p square plus 1. So therefore sec theta is equal to p square plus 1 by 2p. So this is the required expression for sec theta in terms of p. Then we have to find tan theta also. So if we subtract the two equations 1 and 2, then we will get 2 tan theta and sec theta will get cancelled. So therefore, if we subtract 1 and 2, then we get 2 tan theta. Tan theta will be equal to p minus 1 by p. So therefore, 2 tan theta, that will be equal to p square minus 1 by p, since the LCM is p. So therefore, tan theta will be equal to p square minus 1 by 2j. So this is the required expression for tan theta in terms of p. Now sin theta, tan theta we know that is equal to sin theta by cos theta. So it means that sin theta you can write it as tan theta into cos theta. Or we can also say it is tan theta divided by sec theta. Since cos theta is 1 by sec theta. So therefore we can say sin theta will be tan theta, which is p square minus 1 by 2p, divided by sec theta, which is p square minus 1 and p square plus 1 by 2p. It will be p square minus 1 by 2p into 2p by p square plus 1. So 2p and 2p will get cancelled. So we will get it as p square minus 1 by p square plus 1. So therefore, sin theta is this p square minus 1 by p square plus 1. So hope all of you understood the solutions of these two questions 17 and 18. Still any doubts if you have, then please write that in the comments. We shall obviously clarify them. So thank you everyone.